Cool, okay. So hopefully everyone's here for Bleeding Edge MySQL Cluster Upcoming Cool Things, which is the approximate title of what I really should have called it, but don't have to be too exclaiming and profane. So, who am I? I'm a software engineer. I'm a developer. I live in the future. I don't live in what you currently deployed for production. My name's Stuart Smith. I work for MySQL IB on the cluster team. So my full time spent developing cluster, when I'm not talking here. And I'm based out of Melbourne, Australia. A lot of the cluster teams in Sweden, got some guys in Beijing as well. So what to expect in this session? An introduction to upcoming cool things in MySQL cluster. It's not a talk about 5.1, that was the last session. Maybe not even a talk about 5.2, right? Some will hit carrier grade edition. If you really want to grab the source tree as well, it's getting up on BK bits. So you can use the free BK client to do it. Otherwise, I'll probably have some script that makes tuples and stuff as well. You don't want to even use that. This is the future. It's not the present. Do not think of deploying any of this like this year. No vaporware. There is also no vaporware, depending on how you want to spell the word. So everything has actual code. I'm talking about stuff that there are commits and code, existing code about it. So except when I just talk about ideas, but there's not going to be much of that, right? Any guesses on versions where any of this here is complete crap and should be treated as such? No promises of version numbers. So no promises. Interactivity, if you have questions, ask it. No matter how stupid you may think they are, that's cool. Cell phones off, everyone knows that by now. What is it? What is MySQL cluster? It's this. That's all the introduction you get in this session. So I hope you know something. Recently added to 5.1, we implemented MGM API timeouts. So you may know there's a management server API, which is used by the management client. It's also used by some third-party tools. For example, NDBTop is a new tool that's been implemented by somebody that's sort of just out there, random, not cluster team guy, which looks a little bit like this. You have sort of a top-like interface to monitor NDB. So this uses the management API. It's actually running on my cluster at home. So it's a snapshot of how my cluster at home looks like. And there's a reason there's a red failed data node because a disk in the machine died. So it didn't have an OS installed on it at that point. But it lets you easily see what's running and what's not. So you can use the management API to do anything the client can and even a bit more. So to have a HA kind of application doing this, for example, you may want to generate events in some kind of management system you have, or page you when something happens in the cluster. You need to know when the management server dies, so you can connect to another management server. Right? So there hasn't really been support for this. It's sort of was THCP timeouts kind of thing. This is a sort of product of a legacy kind of thing where before the management server didn't really do much. It literally sort of distributed a configuration file and did nothing else more. So as time's gone by, we've had to add more things, people become more reliant on it, do event monitoring through the management API. So you really want to have more of a HA client apps on the end of this. So you can now call this management API function, which is pretty simple. MDB MGM set timeout. Looks a lot like other functions in the MGM API. We have a MDB MGM handle, simply a handle for management server connection, and you get a timeout in milliseconds. So you set the maximum time actually any MGM API function can run for. So it's not sort of like if I don't receive a response for each line in the protocol, I'll do that. It's kind of like this function can take up to this amount of time of network I/O, network interchange. So you can actually roughly have deterministic behavior of your management API client programs. So you don't have to run things in different threads or anything. You can actually say, this may block for up to 3 seconds, which is pretty neat. Backup, I say the MDB MGM start backup calls, don't use it that way, but you can use start backup with no wait and look at the events that are coming through. So the API supports that. The API will now return any timed out on any MGM API function. So it keeps the same calling semantics as previous versions. We just have now, when you get the error, we'll say timed out. You can then reconnect to another management server, and it also works with event monitoring. So you can do a whole bunch of cool stuff like have your own custom application monitoring events and easily connect to another management server if one dies. And this is actually like the one thing today that is in 5.1 that's arguably a bug fix. You can look at worklog 3704, which describes the implementation. All of these things have what we call internally work logs. This is like a record of what work needs to be done. They have work log numbers, and we're working on getting sort of more of these click the public button. So we don't want to publicly have every work log up there with someone like customer specific info, and shouldn't really be out in the public eye. So we have improved management server and API testing. I recently checked in a bunch of infrastructure to do what extra management server and API semantic testing as part of NDB auto test. So I'll introduce a bit to about NDB auto test, which is a test framework and a bunch of tests for MySQL cluster. It's about 3 times the size of my ISM. That doesn't include data sets. This is a whole test suite that is has code that is about 3 times the size of my ISM. So it's fairly comprehensive. It does a lot of failure testing, system recovery testing, testing of node failure during different types of transactions, that kind of thing. It's mainly NDB API based, and it uses error injection into the cluster to test failure. So we actually test, say, during a transaction, at each of these points, fail a node, and then we can test back the NDB API program, part of auto test, and then test to make sure that everything's consistent. So we use a lot of the idea of inject errors into the cluster to sort of like simulate pulling the plug on that node, but at a specific point in time. So it's not kind of like randomly kill that process, it's kill that at a specific time. So we can say what happens if something fails then. So I did a lot of improved management server and API testing, which is sort of Stuart's pet project. The idea to support error injection in the management server. I mean, as I mentioned previously in the past, it was rather simple, but now it's doing a lot more. So we want to also do a lot of error injection and testing inside the management server. And use this to test, of course, the management API to make sure we don't break the calling semantics of the management API. So even applications will be like binary compatible and source compatible for future revisions. Which I think we've actually broken sort of by accident a couple of times in the past, but we want to ensure that this doesn't happen. Which is actually probably more testing than the rest of the client MySQL client API. So I won't say that yet. This is ongoing work. I really hope to sneak it in wherever I can. I am now actually no longer accepting, I will no longer approve a patch to the management server that doesn't have a test associated with it, as in a C++ app that tests that specific functionality. So the idea is to then have close to 100% coverage with lots of test failures. Thank you, evolution. Tells me to update my workflow guidance. See if I don't have it pop up, I just hack instead. So, error injection. Let's have a look at this patch. This is part of the management server code that's for a function called check connection, which simply sends down your API program, sends a string to the management server, say check connection, and it replies OK. Pretty simple ping and pong type action. So we want to test perhaps how timeouts work. Just so we want to test to make sure that if the network cable is unplugged, we get an e-timed out error back. So here we have if error inserted 1, so each error has an ID. We just keep track of these internally and what they do. So if the error inserted is equal to 1, sleep for 10 seconds. So a client should pick up within, if it had a 2-second timeout, that a timeout's happened and return an error to the user. So API program tests that, which is a little bit like this. This you can also see part of the management API. It's a fairly simple C API. First we call an existing management handle, so we've already created the handle, set the connect string, connected. We say we want to get the node ID of this management server. We then insert the error, so that error number. We go to that node ID, insert that error into that node ID. For MGM API, you can do per session or per node ID, but generally we'll test like specific errors in specific node IDs. And say, so what happens if the master fails in that protocol, or the slaves fails in that protocol inside the NDB nodes, and you can test in different places in different times. So you can test the specific point of failure for each node in the cluster. We have a bunch of loops in auto test that just test every single combination. So we set the timeout 2.5 seconds, check connection, and the idea is that should return within about 2.5 seconds later and say, hey, we've got a timed out error. So we check that the result code is correct, and the fact that we have the semantics of then the handle is disconnected. So if someone screwed this up, had a patch that screwed this up, they ran this test, we realized that, dude, you broke the management API, you can't have that in the code. So as I mentioned, you can do per session or per server kind of error injection, which is pretty useful as well. Also inserting more diagnostics into the management server to help if someone hits a bug in it to actually find out what's going on. And the aim is to have fewer regressions. We've had a couple of regressions among the users of the management server. It isn't too critical, you restart it, nobody notices and it all goes on. But it's best not to have these things. Online ad node. It's probably that everyone's looking forward to. Online ad API node. So adding an API or SQL node to a cluster already works. Has for ages. There's a specific procedure to follow for that, and if you don't follow it, you of course deserve everything you get. Making that a bit nicer is of course ongoing work, but of course follow step by step. You know, we've got 1, 2, 3, 4. You know, don't think you can do 1, 5, 3. That's not a good idea. You do a rolling restart in the add API node case. So you change the config, restart the management server, and cycle each node in the series. Unfortunately, it's not alter-cluster add API node. Lofty vaporware I want to implement. But what I really want to talk about a bit today is online add data node. So back in March, some of this stuff worked. In fact, I talked about it at our developer conference, which was about a few months after I'd actually gotten all this stuff initially working. Then other things took priority. Bug fixes, you know, customers actually want their current systems to run well as well. A few other features that got done. So it's a slow-moving patch. There hasn't been sort of huge amounts of various work needed in some of these steps, but it just, you know, takes a while to get all the time to get it done. But progress is promising. Every time we get back to this and have a bit more of a hack, you go, yeah, that wasn't too much effort to get it further. When is going to be the big stumbling block that I'm going to cry over for 3 weeks or months? So why would you want to add a data node online? Well, of course, you may want to expand the cluster to handle increased load and have increased storage capacity. So, of course, the lofty vaporware, I warned you there might be a bit of vaporware, is to take a single instance MySQL server and change it to a cluster as an online operation. Yeah, it's a few years away. But it's like this lofty goal that you have in your head of being able to, like, if you could demo that, how awesome would it be to have an online operation go, we need more capacity, suddenly create a cluster. So back to reality, instead of sitting in lofty vaporware. So the stage 1 of implementing online add data node is, of course, have the configuration be updated and have the node communication. So have the ability at the transporter layer to send signals to these new nodes. So currently how it works is a rolling restart. We change the configuration, do a rolling restart, every node rereads the configuration, and then goes, okay, cool, let's connect those nodes, open up transporters. Future, of course, is some nice magic, removing the sort of ease of shooting yourself in the foot that this process has. So I originally actually, when implementing this, had a shell script about yay long that did online add node properly. And if you deviated it even one step, you probably had cluster failure. So I want to remove some of the ease of shooting yourself in the foot. But that's, you know, future, have the actual functionality work first. So after the rolling restart, we have these new nodes that have sort of joined the cluster. So you'll see them in like the management client output, your NDB MGM show, and they're a node group. And an interesting thing, of course, when we got this working actually really quickly, and sort of, I was in Sweden at the time, in Stockholm, and so like, hey, I'll just go, hey, we got it working, and go to Michael, we have online add node working. It's like, so what does it do? Well, you don't store any data in them, even though they allocate the memory for it. But they could be a transaction coordinator, which turns out to be about maybe 20% of the load of a transaction. So it wasn't completely useless. It was kind of nice to save the patch. So as you know, MySQL servers connect to the data nodes and use one as a transaction coordinator. So this could be useful. Talk to other nodes, many of them send data back. So you have, you know, parallel execution of a query. So the amazingly small patch to have an online add node that acts as a transaction coordinator was actually only changing 3 files and inserting 82 lines of code and deleting 27. So pretty small diff out there. It's not too interesting. Most people actually want to be able to store data in their new nodes. You know why? Make my life harder, but more challenging, right? So there's 2 options of where to go next. There was to add node to node group or add node group. So everyone's familiar with the concept of node groups, cluster and replicas. Cool. So as we know, data is grouped into node groups. Number of replicas equals 2. Just goes here, data struct across. Adding a node to a node group means changing the number of replicas parameter for the cluster. Useful, but not as much as add node group. So increasing the amount of redundancy is a relatively sort of rare operation once you have number of replicas equals 2, right? And going to 1 to 2 is the magical, single MySQL server to cluster. Add node group adds more capacity, right? You're adding a new partition to your cluster. It's also easier to implement. So let's go the easy route first of getting nodes in. So add node group. The idea is you have maybe a 2 replica 2-node cluster and go to a 4-node 2 replica cluster. And new data is spread across all node groups. So if you create a new table, that new table will be spread across all those node groups. Old data is wherever it was before. So this isn't online redistribution of data. It says existing tables that were stored in that one node group, they stay there. New tables will be stored across everything. What do you think? Is that much use? Maybe. Right? That's a lot easier to get to that situation. Online data reorg is actually really tricky. So I implemented this command in the management client. You literally type, and this is actually in the test that I wrote, add node group and a list of node IDs, and adds node group. I thought, cool, this is more of my cluster management language I want to implement at some point. So if you have T1, which was created when it was 2 nodes, we apply hash to the primary key and everything ends up in the same node group. We add our nodes, not in a node group, add node group, we get a new node group. Create a new table, and it's spread across both of the node groups. So this has worked for, oh wow, like a year, as long as you had this patch and didn't want to have node failure in the middle of it. So there's no online data redistribution, and recent work has spent a bunch of time writing an automated test suite for it. So the idea is that then we can implement inside our auto test framework, which I should mention, a test run of the entire NDB auto test takes about 24 hours on a bunch of Opteron systems with a bunch of memory. This isn't like a test run you run before check-in. This is like a more serious regression suite, which finds a lot of problems when you like major restructuring or something. So once auto test passes, especially for a lot of certain areas of the code, you can be pretty sure you didn't fuck up. Hope no one was offended. Developer and Australian, right? So we have automated testing of add node. And I like to take the credit in a joking, humorous way for the implementation of the most evil management API and management protocol function I think we'll ever have. Which is, if you've ever used the management API, you'll know there's a function called ndb mgm get configuration, which you can then download a copy of the configuration and find out what nodes there, what type they are, all that kind of stuff. So I implemented ndb mgm set configuration, which is totally internal, so nobody ever uses it in an app, and it's totally evil. But, and I say, use of this function does harm puppies. Don't infer what that means about me. So what it does is you have we have a C++ class called properties inside ndb, which is simple sort of like key value kind of properties foo that we use to store the configuration internally after we've parsed it from the configuration file. So you read the configuration file in, you parse it, you set things out for like the shorthand we have, so you're not writing a config file that long, you can write one that long. We check validity for all the options, that's an important point, and generate this data structure, which has the ability to serialize it and send it across the wire, which is what the data nodes and MySQL servers do to get the configuration from the management server to find where the other nodes are. So set configuration, you grab one of these objects and send it up to the management server, and then instantly start serving that configuration out with no sanity checking. So the interesting thing that this does is after I spent the time to write the patch to do this, it was actually incredibly easy to add nodes to a running management server. So to do sort of like online node configuration and fooling about inside the management server wasn't too hard, which proves that it's probably not a huge amount of effort to get to sort of a online add drop node without rolling restarts. So this may not be too hard. I haven't done that yet. There should be an N at the front. The slides are also in development. So it shouldn't be too hard to implement that. It just may take some time to do it. And I say possible for 5.2. I keep poking people in the rib and going, yeah, I actually would like at least part of the add node patch to go into 5.2. At least to get it out there and be tested and people can run it. Even if we have it in a state where it's like, Only use this if you really must. Realize that if you have certain forms of failure in the middle, it may, harm babies. But at least have it out there and people to try and experiment. So hopefully also to have it there so it also doesn't bit rot. I have a series of patches if you want to experiment a bit, but keep in mind experimental in the extreme stage. So to do testing, especially in failure scenarios, we really want to have a lot of tests for failure scenarios with something like add node. You want to have really well-defined behavior of like how quorum manages, what happens when different nodes fail, when you're adding nodes at different points, and stuff like that. So there's a whole lot of work to do that before you call this sort of enterprise production ready. To do is also remove rolling restart, which means having, so one of the great properties of NDB is we have a lot of things allocated statically, which means we have deterministic performance at runtime. And we don't sort of sit around waiting for, an hour for the malloc call to return. So having dynamic transporters, which means dynamically resizing some data structures inside NDB, I refer to as lots of fun. We get to come up with a sort of the final solution how to implement that. So, ending independence, another thing that's currently being worked on. So now talking about other people's work as opposed to my pet projects as well. So previously and currently in all released versions of MySQL Cluster, each node must have the same byte order. So you can't have x86 data nodes and PowerPC or Spark API nodes. And it even spits out a warning, which I think was actually the first patch of mine that went into MySQL. Because I had PowerPC laptop, x86 desktop, hey, this didn't work. So the NDB base protocol has supported some form of this. The code sort of needed to be made to work, but at least it's not a fundamental protocol change. So the idea is to have this be online upgrade compatible. We need special cases for some type of data, so it's not just a matter of like flipping all the byte order in every single packet. It's like row strings and all sorts of foo. The patch is being worked on right now. Michael, how's the status going? It's in review. Even cooler.
It doesn't hurt to point out that the reason why some of this is being pushed just with our existing customers is as they're migrating their applications to ATCA-based hardware, they can't go application and database all at once. That they find themselves in kind of this halfway stage where application might be Spark, but yeah, they definitely want to go Red Hat ATCA x86 on the database, so they kind of get stuck in this half.
Yeah, so as Jimmy's saying, this is a big thing for migration of existing apps. Like even recently I was on the forum of the list, someone said, why the hell would anyone want this? Deploying new stuff. Who the heck uses Spark anymore? I think was the actual comment in there. And it's like, well, actually, and they question, like, is there actually customer demand? A lot of players like, yes, we have real customers who say we have these apps running on like Spark boxes we want to use on server-side database like Linux and NDB, but we don't want to have to migrate everything at once and potentially have a lot of points of failure. So yeah, it's actually worth it. It's pretty cool. And you can also run like as API nodes, like a bunch of the Spark CPUs, like the new super amounts of threads inside the CPU, which is pretty cool for some applications. So there's a bunch of some success, a bit more testing and reviews needed. So there was testing needed when I was talking about it. Michael tells me it's in review, even better. So there's a bit of ongoing work. Probably carrier grade first. Just looking for nods, maybe, yeah. Great. So blob improvements as well. Currently blob, the version 1 blobs we have, create table with a blob in there and partition. Looks a bit like this. We create a hidden table, which is a support table, just throw the blob in that contains a primary key from the parent table, a dist and a part number, and then data in chunks. And you have a primary key, which is pk dist part, and distribution key, which is pk dist. And this is all keeping the same kind of blob architecture that NDB has of having blobs implemented in the API, not in kernel. So we use this dist number in here as part of the distribution key to give wider striping. So if you're striping blobs across different partitions. So there's a few problems with the current implementation. You can't partition on A or C. The primary key is a fixed size, even though C is varchar. So it's using a fixed size attribute instead of a var size attribute. And data is fixed size, right? So if you have here we have a data block of 2,000 bytes, and if you had only a 1,000 byte blob, you're going to waste 1,000 bytes in fixed size. And And a point that from NDB API, char set keys can be a bit fun. It doesn't affect MySQL, it's a pattern. So blob version 2 for these. This is for our blob. We have our keys, our A, our int. So we have our primary key here, A, int, and part number. And we can have a distribution key on C. So you can actually have sort of distribution key specific on things. So this means if we omit dist, so if we omit the dist column from the distribution key, so the key we're distributing, partitioning the rows on, it means we can store the blob in the same partition as the row, right? So you have the row and the entirety of the blob in the same partition, instead of having the blob spread across partitions. So if you have a stripe size of 0, so you're having no striping, blob is stored in the same partition as the primary table row, which can mean some things for performance as well as balancing your memory usage across nodes. And if you have it not distro, we add the NDB dist as part of the distribution key, which is not at least yet available from SQL. So of course, in progress patch. Schema transactions. So originally we had tables and attributes. Years ago we had tables and attributes. Can't really have tables without attributes or attributes without tables. Originally, not many tables, right? Most HLR systems that NDB was designed for have like less than 20 tables. Really not many. Now, we have people running hundreds of tables and like thousands of attributes and stuff. We have several syncs to disk during schema operations. Like, that's not a problem when you only create 20 tables when you start the cluster and run forever with that. So this means you have to wait for the disk to actually write stuff to disk during schema operations. And we have tables and attributes and blobs and indexes and triggers and events and all that kind of fun, which are all schema operations, so all doing several syncs to disk. So if you create a table with a few blobs, lots of indexes, a lot of triggers and events around it, you can do lots and lots of syncs to disk, so it'll take a while. So what we want to do is batch schema operations. We want to do all the creation of the helper tables and indexes and stuff all in one operation that we sync to disk, so they'll all be applied on top. So we run that as a single transaction. This also means we can improve reliability in the data dictionary of NDB, and it has better properties in recovery after node failure during schema operations. So this is in the small amount of time a schema operation is going on. We want to have better determinism for recovery after that, which is pretty cool. Which is largely actually isn't really a big dot point schema transactions, but it's just like improving reliability and performance in some areas. So, improve MySQL Server performance. Michael talked a lot about this in the performance tuning NDB stuff the other day, so I won't go into huge amounts of depth. So, MySQL Server creates a single connection to the MySQL cluster. It's a single API node. This means it has many send threads, many connections to the MySQL server. It can also send stuff to NDB nodes, and one receiver thread. So one thread inside the MySQL server that receives all the messages from the data nodes and dispatches them out to the MySQL server connections. And it looks a little bit like this, right? Many connection threads inside the MySQL server, talking all over the place. One receiver thread that gets everything into it and then distributes out. Fortunately, this doesn't really scale out to, I think, numbers about 2 CPUs. Yep, Michael nods. There's a bunch of like lock contention and foo in there as well. So we found out, and actually one physical machine, when you have a number of CPUs, you get high throughput from just running multiple MySQL servers in the same box. So this has been sort of like the workaround. You have like quad-core CPU run like 2 MySQL servers, and you get high performance and better CPU utilization. So what does this mean you could do? Well, you could do the sort of the cheating of either running multiple MySQL servers. You could cheat even further and just have a single MySQL server use multiple connections to the cluster. So it has sort of multiple receive threads, but in sort of like different connections. Remarkably simple yet effective, right? So of course the proper fix is to remove the lock contention, do a few more foo internally, and that's sort of on the radar. But in fact, having a parameter of number of API connections to use to the cluster for the MySQL server gives you a fair bit for a small amount of code. And we allocate these connections to the threads, so the internal object in the MySQL server that really means a connection to the database, in sort of a round-robin fashion. So you load balance out between these connections and have less lock contention. So probably the rule for setting this parameter is like number of CPUs divided by 2, I guess. Data node scalability. Michael talked a bit about this as well. So it turns out if you have a lot of sockets, so a lot of nodes, calling select or poll has a large overhead. So set that up, run it once and cut it down, can actually take a fair bit of CPU time in the scheme of things. And you don't want to spend a lot of your time just simply asking the socket, is there anything there, is there anything there, is there anything there? So on Linux we can use epoll, and other operating systems have other food that does it, no likely not as elegant. So we use epoll in Linux, reducing greatly the CPU time we spend in large clusters, just checking if there's any messages to receive from other nodes. So this really helps when you go up to large number of nodes as well. Change the net maximum number of data nodes. Currently limit is 48. It's patched to go to 64, 1 to 127. I'm not sure about that though. 128? Actually 128. There we are. I'll just change the slide. So maximum number of API nodes. There is a patch exists that increases it up to 255. Which is pretty cool. More API nodes accessing the same cluster. There's also been work on partially connected API nodes. This means API nodes that are not talking to every data node in the cluster, which means something for API nodes maybe on different network topologies than other data nodes, through like that. So it can actually route data from specific data nodes through another node to get back to the API. I'm not sure what the status of this patch is, but it improves when you don't want to have certain network links be used. Multi-threaded NDBD. So the NDB kernel architecture is inherited from the AC system of Ericsson. The basic idea is it's a mixture of blocks and signals, blocks being software modules, and signals being the only means of communication between the blocks. No data sharing between the blocks. So you don't have like huge shared data structures or anything. You send signals. Signals are local or distributed, so you can send a signal to a block that is local on your node, or send a signal to a block that is on a remote node. We have statically allocated data structures, so we also don't use pointers within the code. We don't want to futz around with sending like memory locations across the wire and use those for reference. That could be huge kind of security issues and stability issues. So we use logical indexes into data structures, right? And we do runtime checks for index out of bounds. So instead of having like a memory location of where the transaction object is, we have its transaction object number 4. We have entry methods for signals inside the code. We have a function that says this block wants to receive this signal and call this function when it happens. And then we of course implement that function. So if you have a look at the software platform, we have a bunch of blocks sending signals between each other. We have this virtual machine kernel down the bottom that organizes sending signals and executing them. So the virtual machine is not bytecode. It's nothing like a JVM. So don't think of it in that terms. Simply think of it as a base bit of code that provides job scheduling, a bit of operating system abstraction. So the implementation using poll and epoll and selecting stuff, that's all handled by the virtual machine kernel. None of the actual rest of NDB has to care about that. So if you suddenly ported NDB to an operating system that didn't do that, it suddenly sort of had magic stuff appear in memory, or a call called check sockets or something. You just change the virtual machine kernel and everything keeps working. It also provides like sending and receiving of signals, so like a transporter implementation. So the virtual machine is currently a single-threaded implementation. The concurrency model is job switching, so executing a signal is a time slice. So we have very inexpensive context switching. So unlike a server that may spawn 1,000 threads for 1,000 connections, that would mean changing the whole register set in the CPU and doing a bunch of other things within the CPU. We just grab the next job in the buffer, so we grab the next signal and execute it. This of course requires that blocks cooperate with each other, so you write things carefully to relinquish control within a reasonable time slot. So a signal can't take 10 minutes to execute. It needs to take much less time to execute, so you want to execute the heartbeat signal and reply to the heartbeat. But since we control, all the code executing in NDB, this is quite possible. So it sucks for like an operating system implementation, and anyone who used classic macOS for a number of years will know this. But for a controlled environment, it works really well. So job scheduling. We have a signal buffer, jobs are executed from the signal buffer, we have signals in there. If you look in the kernel scheduler, thread config CPP, fast scheduler CPP, we have multiple levels of scheduling, so we schedule between performing jobs and send and receive on transporters. We have different priority use signals as well. So the idea of inside the kernel, we have select on all transporters, say, is there any signals to add? Receive signals, check time signals, is there any signal we should execute at a certain time point? For example, heartbeats. If you want to constantly say, do I have to send a heartbeat, do I have to send a heartbeat? Just say, I'll send one in 300 milliseconds or whatever it is. We then want to execute signals, go spend the time executing a whole bunch of signals. Then after we've done doing that, they've probably generated more signals to send. For example, sending back the data that the transactions asked for. So we send the signals to the transporter buffer and loop. So, multi-threaded NDBD. How do you do this when you have no locks? So the amount of times we call like pthread mutex create or pthread mutex lock in NDB can probably be counted with all the digits you have. Like fingers and toes, as in just with helper threads, we do some stuff there. Actually mostly in the API, but in the kernel, that's not what we use. You don't have like pthread lock wait times, which absolutely kicks ass. Personally. So, a bit of the idea is to have something like the virtual machine running on each CPU. Like traditionally, if you wanted to use multiple CPUs, you start multiple data nodes. Have a bit of this idea, except optimize this environment. This is all like highly new work that's still being worked on kind of deal. So the idea is that to send signals between CPUs and have this implemented not with like a TCP transporter, sending TCP packets between CPUs is really fast, but not as much as sending a buffer of memory across. So we use an ultra-efficient method of sending signals between CPUs. There's a couple of patches that Jonas has checked in, which is pretty quite cool as well. Basically you want to use maybe a buffer per CPU, maybe the size of a cache line, and bump that across. Current status, I think multi-threaded NDBD works for a short amount of time. This is what Jonas was telling me over the desk a couple of weeks ago. Work continues, so it's not near done. Create table doesn't work yet. So there's bugs in create table, multi-threaded NDB. So this is the kind of, this is like pre-alpha stage, but things are promising. But what is promising, of course, that you can do an online upgrade from a single-threaded NDBD to a multi-threaded NDBD, and this is how tests are being run. So promising performance so far, using this kind of implementation architecture is looking quite promising to have really cool performance on a number of CPUs. And I'll talk now a bit about online add attribute. So this is online add column, attribute column, depends which camp you're from. So we needed a bunch of work inside the MySQL server to support online alter table. There's the generic copying alter table implementation that everyone's used to, which turns out to be great. You can alter anything to anything, but didn't even really inform the storage engine of this happening. There was work in 5.1 done to do online add index and online drop index, but didn't actually work for arbitrary table. So since in NDB we use variable sized attributes, we're also going to use this for online add column. So variable sized record looks pretty easy. We have so the header there on the record, we have a fixed size part and a reference to the variable sized part of the row. And then we have all the variable sized attributes. There's really varchar column and stuff. So in our implementation of online add attribute, nulls use very little space, as you just need to mark that column is null. You don't store blanks amount of data. Trailing nulls use no space, as in 0 bits of space. If you add a column and every row happens to have that value of null, and it's the last column on the table, that column literally uses 0 bits of storage. I think it's cool. So let's have a bit of a look at the online add attribute row format. We have a bitmap, we have a var size position array, we have our var size data, and we have a bit of padding, and we have fixed size data. This also allows you to do online add column of fixed size columns and have nice predictable performance that of searching through a variable sized set of rows. Set of columns, rather, attributes in the row. So this allows you to have also better kind of like deterministic performance with certain type of attributes, if you really care about like real-time related stuff. So it looks a bit like this. We have a bunch of columns, and we have a bitmap there saying what's set to what. We have a bit field in here, where is it, bit 20, and the bit field is just stored directly in the bitmap. So we save a bit of space. We have fixed size data here. We have two char columns that has A and B in it. So we have fixed size stuff at the end of the var size part, which means we can simply use calculations of offsets to directly pull that part of memory. And of course we use stuff in the bitmap to indicate whether it's not. We have the var size position array, which means we have to look that up to find in the var size data part where that column starts. So there's a bit of extra computing there. So you have many columns and many different things in there. It has a little less real-time behavior, but in reality this is all really, really quick, and every single application doesn't care except real-time ones. Char 8 over there, char 4, varchar here. So your 100 varchar is only using a few bytes here, which is pretty neat, and the char 4 is using the full floor space, fixed size column, and the varchar 100 there as well. Bit 20 had an arrow in there. So adding columns changes metadata only. This isn't doing something like examining every single row and changing it and then storing it back in and taking an hour. It just changes metadata. So it doesn't actually require changes to data, which is pretty cool. The row format has been specially designed for space and CPU efficiency. So it's actually really, really fast. We use like bit counting stuff, which is like, what, 11 CPU cycles or something to find out where stuff is in the column. Something insanely efficient. So we have a rather efficient implementation of online add attribute. And currently, maybe a week ago, we actually had even the SQL syntax working in the preliminary stage, so you could actually type alter table add column, and it would complete a fraction of a second and have new columns in the table, having zero amount of downtime. Also been implementation, Mark will talk about avoiding read before primary key or unique key updates or deletes without expressions, which happens to remove about 8 primary key lookups per transaction for DBT2, so increases a whole bunch of performance. So if you do an operation on a primary key or a unique key without a where condition, so it's just that key, we can actually send directly to the data nodes to go, hey, update this row to this, or delete this row, instead of having to read it in, find out what's changed, and do that, which is pretty cool. Better transaction coordinator selection. So the idea is when we scale to many nodes, we want to select a transaction coordinator that's better for us. So when we have many nodes, we have selecting the correct transaction coordinator becomes a limiting factor on performance. And about how many nodes is this? Michael, do you reckon? So 2, it doesn't really matter that much, but when you get up to large data nodes, it becomes a thing. So the idea is to select the transaction coordinator based on data locality. So the current implementation of MySQL Server does round robin style. And from NDB API, you've been able to do some of this in existence, but Michael's work does it for in the SQL Server. So the MySQL Server now has some smarts to do this. Or will have some smarts. If you use the benchmarking tree, then it's there, sure, as well. So we want to select a transaction coordinator that's local to the data. So if I remember correctly, the way it works is that the first row you access in that transaction, we use the key for that and select the transaction coordinator from there. And that means that that row is going to be stored local to that transaction coordinator. So for example, if you're doing like a key operation, it'll just be in local back, one network hop each way. There's also something we call NDB record, which is NDB API improvement. Currently we have a class called NDB rec attra, which it's been useful and fine. NDB record is a different implementation that also helps us allow to have tighter integration with the MySQL server. And also it lets us have a closer mapping between what comes out of NDB and what the MySQL server row format is. So MySQL expects you to fill things, the MySQL server inside the handler expects you to fill things in like a row format for MySQL. So the more efficient your engine can turn however it stores things in the engine to this row format, the quicker you can get it back to the user. So this means you can do like less copying of data if your storage format is different, and we have some special things to make sure we actually take things sort of directly out of NDB API in exactly the format the MySQL server expects. It also has less error-prone NDB API programming and a whole lot more efficient as well. It is faster. It's not like the primary limiting factor in performance for every single MySQL server related thing. So this will help along with all of the other work to get better performance in API applications. And like recently, like within the past like 2 weeks, so that's actually been like the first benchmark run micro benchmark around this kind of code, and it is actually substantially faster. I want to pimp something that was checked in actually while I was at the conference, but I actually made the patch for ages ago. It's just hard to find the time to get someone to review the functionality when it's a giant wieldy curl script and have the time to check it into the tree. So maybe where NDB size PL does estimates on how much space your current data set is going to require in MySQL cluster. That's especially important for when you're using like 4.1, 5.0, and even 5.1 in regards to how much memory you need in the machines. So I've made it more accurate. It's now more likely to give you an answer that's close to being correct. It's more flexible as well. I'll talk about this in a second. So it actually lets you now dump out the entire queries that NDB size passes to your MySQL database, including it does things like how many rows you have. So it works out how much storage you need for how many rows you have. So you can actually change that number. So you can say, although I really have 2 rows in my database, what happens if I had 3 million? And you can then run a calculation based on that, which seems to be useful. So that's like in 5.1 tree now, if you pull it. Certification is a new thing as well. I've talked a bit about this. We have separate certification for MySQL cluster because, as probably everyone in this room is aware, you require additional knowledge than just MySQL server knowledge, and additional skills as well. And it's different than plain MySQL cluster, not the same as single MySQL server. You have to consider things about high performance, you have to consider things about high availability. So the certification is around now. Some people have taken it, like here at the conference, it was like really recently done. We have Notting and...
Yeah, just a few hours ago.
Just a few hours ago. So what were your thoughts? Quite interesting.
You could probably use it as a method of interrogation in some countries.
Yeah, we wanted people to it was a
good test.
Yeah, it was a good test. You really have to know what's going on. So that's something I've spent a lot of time working with people on over the past. It's taken us 8 months to write the certification study guide. Something that began 8 months ago. So this was sort of part of that process as well. It builds on the DBA certification. So you've probably done the DBA cert as well. Yep. And as you know, if you didn't know everything in there, you'd probably be lost on all the MySQL server questions in there. So you have to know also MySQL server stuff pretty well. So we also test the way that interacts in applications. And it's really designed to ensure a solid baseline knowledge. And it's not like details of NDB API and how all the internals work and everything like that. Maybe it can be like a MySQL cluster, a demigod certification or something later. But it's designed to ensure like a good baseline knowledge. So the idea is to have that I wanted to make sure that if someone had that certification, it would probably be pretty good for them either setting up a cluster for production or actually monitoring and using one in production.
Is that a 2-part certification like the other ones or not?
No, it's one. So there's a study guide as well, which is a book that is nearly out. One of the co-authors on that. There are other MySQL cluster sessions at the conference. If you're interested in the NDB API, have a look at Johan's talk on using NDBJ. A customer, George from Ericsson, is going to talk about using episode program guides for IPTV. He's actually using it in a telco application, which is pretty cool. Monty is doing like ORM on steroids, funky cool stuff. It's the woohoo talk, which would be pretty cool. Doing a bunch of stuff like having interesting connectors, so using a whole bunch of different languages to write NDB API applications instead of just C++, which is pretty cool. The BOF has already happened. I've had no time to update my slides when we hadn't had the BOF scheduled.
Wait,
So,
it's not tonight?
no, it is tonight.
What BOF did you go to?
Sorry, let me go. I have no idea what day it is.
Did you think you were there?
No, I'm having enough problems holding on to this other side of the earth and not falling off. So the cluster BOF is tonight, which will be cool. I'll be asleep. It'll be really cool. So enjoy the conf. Don't be afraid to come up and ask questions at any time. It's one of the reasons why we're all here. We're a friendly bunch of people. We're going around like all week, so around tomorrow as well. And join us for lunch. I'll be around. I'll be the guy saying where's food I can eat. Join us for dinner as well. Be around tonight trying to grab some food. And as well, join us for a drink at the bar. That's a good thing. Well, I'll have it tonight after the bar. I'll be good to have it. Feedback's appreciated. Hopefully you've enjoyed the session. And feedback from Cluster as well is pretty cool. So thank you.